Okay, so I will start this video by giving a quick recap of what I had covered in my previous video on integration. So we had started, I'll just draw it in steps, okay? So we had started by taking a graph. Wait, it started at the origin, right? Sorry. Yeah, there you go. So we had started by taking a graph, x square versus x. So that graph, we had made two boundaries at 1 at x equals 1 and at x equals 2. Then this was a problem, right? The problem that we were given, and then our aim was to find the area of this shape here. So what we did was divided this into a few rectangles. Okay, so I'll just draw a few rectangles there. Yeah, that's it. I won't draw all. Okay, I'll just draw all of them. 1 2 3 4 5 6. Not a very good drawing, but yeah, it'll do. So I had divided the whole shape into many rectangles. Then what we had done was, okay, at this point we need to remember one more thing. Here I had drawn six rectangles, but our actual aim was to increase the number of rectangles as much as we can. What would that do? That will actually make an approximation better. Remember, this is an approximation. The area of the rectangles is not exactly equal to the area of the whole shape of this shape, right? But we had made an approximation that the area of these rectangles is almost equal to the area of this shape, which is not true. That will be true only when the number of rectangles is very large. So here we are doing with 6 rectangles because I can draw many rectangles, but later I will increase the number of rectangles. Okay, but for simplicity's sake, I am keeping it to 6 right now. Okay, I'll come to that later. Okay, so what we done after this was, we had taken these rectangles, trimmed and pasted, copy paste, and did all that stuff, and tried to make all of them equal. We did not change the width of them, but we changed the height of them. And what we had come up with was, so we had got 1 2 3 4 5 6. We had got 6 rectangles. So 1 2 3 4 5 6, 6 rectangles. I know the width does not look same, but actually we had tried to keep we had kept the width same. Okay, we did not change the width of the rectangles, we only changed the height, and we made the heights equal. So this length here is equal to this length, this stays the same, and we know this. So now our aim was to find this area, which we had approximated as the area of the rectangles, and then the area of rectangles. So then we had rearranged those rectangles as this, and because we had just rearranged them, the area of both the figures is the same. So if we find this area, you can find that, and then we can just find that. Okay, so here we know this, and we had to find this. So now let's start at this point. Okay, so what is your best guess about what this can be? My guess, honestly, is that I guess this should be the average of all these heights. I mean, I think that is what my intuition says. Okay, but I think I can prove that mathematically also. So let's try that out. Okay, so assume that the width of each rectangle is, let's say, a. Okay, so this width here is a, which is the same as this width, right? All of them are equally wide. Okay, all these rectangles, and they stay the same here. So even these are of equal width. So all the rectangles are of equal width. Okay, so now what is the area of this whole figure? So let us say this height is h here, capital H, and let us say the height of all these rectangles is h1, the first rectangle, h2 the second, h3, h4, h5, h6, 6 rectangles. Okay, so what is the area of this figure first? This should be, so we have 6 rectangles, so this whole length will be 6 times a. Okay, and if you multiply this by this, we get the area of this whole rectangle, and which is 6ah. And the area of this figure, the rectangles here, that is simply the area of this plus this plus this plus this plus this plus this. Okay, so what is the area of the first rectangle? Well, it is the height of the first rectangle, which is h1, height of first rectangle, times the width a. Okay, plus the height of the second, times a, plus the height of the third times a, height of the fourth times a. I'll just write it, okay, here. Height of the fifth times a, and height of the sixth times a. So this is the area of the first rectangle, the second, third, the fourth, and the fifth, and the sixth. So this whole expression gives us the area of this whole shape, the rectangle thing. Okay, and because they are made up of the same amount of paper, if we had drawn them on paper, so the area of both of them is equal, and now I can just equate them. Now let us just do some mathematical manipulation. I just simply take a common. Okay, I can do that. I just keep it here. H1 plus H2 plus H3 plus H4, 5, 6 there equals 6AH. Now I can just cancel the A's on both the sides, and I can okay, and what I get, okay, what I get is I just flip the sides. Okay, I am just writing this thing here. Okay, so I'm just flipping these two, don't get confused. Right, H1, H2, H3, H4, H5, H6, and now I'll just shift the 6 to that side. Here it goes. I'll just get this here. Pretty simple math. Okay, and this is the expression that we wanted. Here this expression gives us the value of h. So this, what does this say? H equals the height of this plus this plus this plus this plus this divided by 6. What is 6? 6 is the number of rectangles, and this is the way we find average. Okay, if you remember, by adding the heights of all of them divided by the total number of rectangles. So this clearly shows us that the height of this whole thing, or all the rectangles, which is the same thing, is the average of the average of the heights of all these rectangles. Okay, so this is one fact that we need to keep in mind as we progress. So just write it somewhere. And so now let us just see where we have reached. So now there's only one thing that we had to find out, right? The height of this thing, which just comes out to be the average of all these heights. So now we no longer need this shape. Why? Wait, okay, let me just tell you. If we can find the average of all these heights, we simply find h, and if we get h, we know this width, which is 1. Okay, 2 minus 1, 1. So we know the width, and we can find h using the average, by finding the average of all these heights. And if we can find the height of this, if we know the width, we can find the area of this rectangle, and by that we can find the area of this, which is equal, and then we can find the area of this, and we solve our problem. So our whole problem just comes out, narrows down to finding the average height of all of them. Okay, so now let's try to find the average height of all these rectangles. Now at this point, we can actually increase the number of rectangles. So as I had said earlier, I'll just remove this part. So as I had said earlier, 6 rectangles is not a very good approximation. So now I will increase the number of rectangles, and to increase the number of rectangles, we need to reduce the width of the rectangle, right? So what is the rectangle with the least width that I can draw here physically? So I hope you agree that this is a rectangle. Almost. This is a very thin rectangle, but after all, this is a rectangle. If I consider this edge to be a straight edge, that is a straight edge, and that is what a rectangle is. I mean, if I've drawn it straight, I try to make it as straight as possible, but this is a rectangle after all. So now I will divide this shape not into 6 rectangles, but into many rectangles which are after lines. Okay, so these are rectangles, right? So I'll divide the whole shape into many such rectangles, not 6 giant rectangles, but into many such rectangles. So then let me just try that out. So I'll just remove this part now, and what I do is, now I take my shape, okay, 1, 2, and now I start dividing into many rectangles, into straight lines or rectangles. So this is the thinnest rectangle that I can draw using this marker, and I'm trying to divide it into as many rectangles as possible. Obviously my drawing is not perfect, but here I've tried my best. And now as you can see, these rectangles cover almost all the space, right? So if I find the area of all these straight rectangles, very thin rectangles that I've drawn here, add them up, I will get the area of this whole shape. And that area will be very close to the actual, the area of all these thin rectangles will be very close to the area of this actual shape. So now I can actually find the area of all these lines, and this approximation will be a very good one. So I don't need to worry about that this my area is actually very close or not. Okay, so I'll now proceed with this diagram ahead. So now I can just do the same thing with this, cutting all the lines or the thin rectangles and making their heights or length same, and this is what I end up with. Okay, many rectangles with the same, wait, same. Okay, so wait, I'll just make him. So what I do here in this step is I take all the lines, cut the long lines, and take that extra part and join them to the shorter lines and make them equal. And as I had discussed earlier, this height, the height of all these lines, which is equal, that is the average of all these lines here. Okay. So to find the area of this rectangle, to find the area of this shape, I had to find the area of all these rectangles, and which is equal to the area of this giant rectangle. And this width was 1. I had to find the height, and height was the average of all these lines. So now let us find a way of finding the average length of all these lines. Okay, so here at this point okay, so I'm ending the video here for the reason because I don't want to make the video very long and confusing for you people. And I think what I have done, I think this is enough, and I think you should watch the video again and try to absorb the idea of what is going on. Okay, because the next part of this video is going to be, next part of this topic is going to be a bit more complex. So I before you watch that, you should actually understand what is going on in this whole scenario and understand what I just done. Okay, this in this video and in the video before. So you have to maintain the track. Okay, so keep the record what is going on in this whole topic. Yeah, and that's it.